Please welcome Senior Developer Programs Engineer, Eric Bidelman.
Hi everybody, welcome. Thank you for coming. So if you came to my last talk, this one's going to be completely different. All that stuff in the bleeding edge HTML5 talk was, well, bleeding edge. It was the latest, it was the greatest, stuff that's very, very new. This presentation, this modern web apps and how to build them, is going to focus more on some of the APIs that have been here for a while that you can use to build modern web applications. So if you missed any of my contact information before, or you weren't at my last session, I'm on Twitter, I'm on Google+, I have a blog. Feel free to tweet at me, to Google+ post at me. I'm a developer programs engineer, which means I travel the globe. I talk to developers about HTML5. I love it. I think it's the future. I get really excited about it. So feel free to come talk to me, at office hours after the presentation if you want to chat about HTML5. So what are we going to cover in this presentation? We'll talk a little bit about what is a modern web application. What does it mean to be a modern web application? How do you build a modern web application? And then how do you achieve this greatness? So some of the APIs and techniques you can use to build a modern web application after we go through exactly what that is. And then once you have this cool thing built, how do you share it with users? How do you get eyeballs on it? That's very important, right? We build something, we put our sweat and tears into it, and we want to share it with others. So my equation for building and exactly what is a modern web application is very, very simple. So it's utilizing the power of the cloud, right? Cloud computing is there, it's here to stay. Whether it's with Google App Engine or some other service, all your data is stored in the cloud. You can access it anywhere at any time. And so that's powering your back end of your application. Now you combine that with the richness and capabilities of the desktop world, and what you get is a modern web application. It's a very simple equation, but I think it covers 90% of what a modern web app should be. Of course, the way we get to that second point there, making it native and as rich as the desktop experience, is through HTML5. And you saw a lot of this in the keynote. You may have seen it in my last presentation or in the various other HTML5 presentations today. But there's a whole umbrella of technology in HTML5 that allows us to do real-time communication or WebSockets or workers offline. This stuff is here, and it's only getting more powerful by the day. Okay, so I want to sort of get your brain thinking about what a modern web application is and sort of what we look for in a modern web app. This first example is called SpringPad. This is a web application that takes up the entire screen. It's very task-oriented, so there's extremely tight focus. I come to this application for a reason. I come to it to create a notebook or to do task management. So the user comes to your app and they want to interact with it. They want to engage with it, and they're there to get something done. So in this case, we're creating a notebook. So your app should have some kind of purpose behind it. Thank goodness this is after lunch, because this one always makes me very hungry. A rich web app should be just that. It should use CSS3 and rich visuals. We have web fonts and all these layout capabilities now in HTML5 and CSS. And so we can really leverage that. This is a web application. It's a food application, so big images make a lot of sense. But you'll notice there's no links at the bottom. There's no copyright links or navigation links. People come to this app for a purpose, and that's to check out big images of food. Another thing you can do is take advantage of things that people already know about. So, this is an example. This is a web application, but it looks a lot like a desktop slide creation application that you're probably, familiar with. So what they're doing here is using, layout and visuals that people already know, paradigms that people already know how to do, and using that inside of a web app. And so the really fundamental thing behind this, and throughout this entire presentation, is build a great user experience. And you can do that, again, with HTML5. That's how we get to this great user experience. So let's see a quick demo of some of the things I just mentioned and some of the things that we'll talk about. This is called I/O Reader. This is a news reading application that we created for Google I/O. And what we wanted to do was to actually write one application with the same markup behind it, but have that application run across different devices. So it should work on tablet, it should work on TV, it should work, of course, on the desktop browser, and also the mobile browser. So we created one app that kind of works everywhere. And for the desktop case, we put keyboard events in it. So I can navigate through this web app using the keyboard, using common things that people know how to do on the desktop. By pressing down, I can cycle through the news and load that up. You'll notice as I'm doing this in the URL, this is a single page web application. And as I go through this, the URL is changing on the fly. So we're using an API we'll talk about, the history API, to do that. So we can provide deep linking back into a particular section of the application. And I mentioned what we've done here is created one app that works pretty much everywhere. So we created a tablet-sized version. Let me scale this down to around a tablet. And so the first thing you'll notice, well, you probably notice there's no images, but that's okay. Something's broken. But the look and feel is completely different for the tablet, right? Different CSS. We're actually using different JavaScript. So for the tablet, let me find a better one here. Well, for the tablet, we have things like touch events, right? You should be able to inertial scroll on the tablet, whereas in the desktop case, you're using the keyboard or you're using the mouse. So let's load only the JavaScript and CSS for the tablet version that we need. So we're not loading extra JavaScript, no more, no less. We created a phone version as well that looks even different than the tablet and desktop version. And so this one has things like gestures and swiping and whatnot. So it's a completely different app across different devices, but using the same underlying code base. Cool. So the question becomes, how do you build something like that? And that's just one example of a modern web application. And so the point I want to make across the entire presentation is it all boils down to a great user experience. How do you get to a great user experience? And the very first thing you do, or at least in my opinion, what you do is really lower the barrier to entry. Make it super, super easy for users to use your application, to try it out, to try it before they buy it, so to speak. If you need something like a username and password, right? A lot of people will try out an app for the first time, and then they get to a form where they have to fill out a bunch of information, and then you lose people because they don't want to take the time to create a login for your application. So if you do need that, something like OpenID is absolutely the right answer. Now, OpenID is hard if you've ever tried it. So Google has what's called Google Identity Toolkit that you can use, which is a great little library. For a lot of the popular services, it'll just wrap that OpenID. You can drop that in your site and really have people engage with your site if you need username and password. So that's called Google Identity Toolkit. You saw in the demo I showed of I/O Reader that we had different JavaScript, different CSS for each type of device we were on. And so the one thing that you should always do is try to have a responsive layout. So if a user is visiting your application on a tablet, they have the tablet experience. If they're on a desktop, they should have the desktop experience. And to do that, the way we styled it differently for each type of device was through CSS media queries. Now, CSS media queries are fantastic if you've never used them. Basically, on my style sheet, we'll have a base style sheet that we'll use across the entire site. So if you visit this on a desktop, you're just going to get this core style sheet applied to the page. And then if I visit this same site on a device that's maximum width around 480 pixels, so that's probably like a smartphone type device, you can say, hey, load this style sheet if I'm within this range and I'm on a screen device, so a phone device. Let's load the mobile style sheet. So in that way, we're only loading the CSS that's relevant to the mobile world, right? We'll just load in the mobile style sheet that changes the base style sheet a little bit. So that's how we detected and changed the styling of the page for the devices. And very similar to that, in JavaScript, we can also use CSS media queries using window.matchMedia. And so we'll do the exact same thing, window match media, and if we're in that 480 range, let's asynchronously load the JavaScript for that device. So we'll load in mobile.js, for example. Now, if we're between around 481 and 1024, we're probably within the range of a tablet device. So then I can load in the JavaScript for the tablet. I can load in the inertial scrolling and the touch events. But let's only do that, right, when we're on a tablet. And this is exactly how you detect what type of device you're on. So this page is set up to do that. So right now it's detecting us as a laptop type device. And so as you can probably see as I change this, we're within that 1024 range. So we're around a tablet size. So it's detecting that using media queries and match media. And if I take it all the way down to a phone, you can see that, of course, the phone then is within that 480. So we're in JavaScript, and we just changed what we're being detected as. So using responsive form factor detection is the way to create this sort of one app that runs across all kinds of devices. There's a great library called FormFactor.js. If you're interested in media queries, it makes this stuff very, very simple. And they've done a great job with the library there. So check that out. The next thing you saw in IO Reader was that it was a single page application. And so we're moving away from a website, the idea of a website, right? We don't have sort of a bunch of pages that people click through. That's a website. A web app is different. It should be a single page that you have deep linking into. And so the way you do that is with what's called the HTML5 history API. And so let me pop out a full screen here. This HTML5 slide deck is actually using the history API. As I navigate in between the different slides, you can see the URL is changing on the hash. And so if, of course, I refresh this page, it's going to deep link back into that exact slide. But what it's also doing is using the API to store that state. So I can basically push pages, if you will, onto this history state. So I can navigate the slide deck with the arrow keys, or I can also navigate it with the browser keys, with the browser's native back and forward buttons. So it's really awesome. That's using, again, things that people know and have gotten accustomed to for a long time. So history.pushState, we're just pushing on, in the example of the slides, we're pushing on the slide number. We can push on a title. So this is the title that gets pushed on to the back and forward buttons. And then you can basically change the URL of the application without refreshing the application. To actually hook up to the back button, we're listening to the pop state event. So we'll add a new event listener for pop state. And then in our callback, we'll just update the URL based on the slide number. So let me show you a couple of really cool examples of using the history API. So this example is actually twofold. This is called Levi routes. It's a great library that encapsulates a lot of the history functionality. But how many people use GitHub for version control? Great. I personally love GitHub. It's fantastic. And they're doing a lot of great stuff with HTML5. They actually use the history API inside of their source viewer here. So for instance, if I dive into the test folder, you can see the URL changed, but it's using history API to update that URL. I can deep link back. I can use the back button to navigate back. So that's exactly what they're doing is changing the URL with the history API as you navigate through the different folders. Another nifty demo is sort of this infinite scroll. A lot of people are doing this infinite scroll technique. But this is just a bunch of tweets. So you can see as I scroll down the page, this URL here is changing. It's just changing a parameter. But we're not refreshing the page. We're not doing anything with Ajax. He's literally just changing the URL without any refreshes happening. And so that's using the history API to do that. Of course, if I hit that URL again, it's going to deep link back into that particular section. So it's a really cool, interesting example of using the history API. So that is how you achieve the single page application. Now, another thing that people are going to do very often in a modern app is interact with it via the desktop, right? If you have an interesting application, you're probably importing picture files or music files or any type of file. And of course, one way we do that is with the input file type, right? This is our good old friend. He's been around for a while. Excuse me. But with some of this new HTML5 stuff, it's really expanding on what is already there. So with a single attribute, right, the WebKit directory attribute, we can completely change the way the file input works. So let me actually get out of, no, I'll stay. So this is just an input file here with the WebKit directory attached to it. And what Chrome is going to do, what the browser is going to do, instead of giving the user the ability to select a file or multiple files, we can select an entire directory of files. So think of yourself building a photo sharing application where you're importing a bunch of photos. The user can select an entire directory of photos, and then you can upload all of that to the server recursively instead of creating a single input for each file. So I'm going to select this folder. And what we get back with a little JSON and jQuery magic is exactly the folder hierarchy that was on the native operating system. But now this is in our web application. So I can import all of these files if I wanted to inside this web app. And so the way this works is with this directory, you get this property. For each of the files on the onChange event for that input box, we'll just list all the files, and this WebKit relative path, this property here, basically gives us the hierarchy inside of each of those folders. So Chrome has recursively read all the files in those folders, and then we can use that to upload the entire folder to the cloud, for instance. It's really powerful stuff with one attribute, folder upload. Next thing we can do is, again, take advantage of things that people already know how to do from interacting with native applications. So this is an HTML5 slide deck. It's a web application. Think of it as a web application. But what I can do is interact with it from the native operating system. So I can import files with the file input, which you just saw, or I can actually select files from the desktop, from my actual operating system, drag those into the web application, and using HTML5 drag and drop and the file reader API, which is a new API to read files in JavaScript, I can create a really cool little photo gallery with a few lines of code using a little bit of CSS3 transitions and transformations. So again, that's using something people know how to do, drag and drop folders and files, right, from the desktop world. And the way this works is using the file reader API, we can asynchronously read each of those files that the user drops as a data URL, and then set that data URL to the source attribute of an image tag. Another thing that people know how to do from the desktop world is cut and paste, right? Whether it's keyboard shortcuts or doing it the old-fashioned way. So I'm going to go ahead and copy the HTML5 logo from HTML5 Rocks. And I'm not copying the URL, I'm copying the image itself. So we'll copy the image to the OS clipboard. And then in our web application, we can listen for that event, and I'm going to press Control-V to paste that image directly inside of the web application. So that's really awesome, right? You're in another native app, you copy a photo, you copy a music file, and you can literally paste that data inside of the web app. And so the way I did that was to listen for the onPaste event inside of the body. And what I get back is the event's clipboard data. So I'll just iterate through the items of that clipboard data. For each of the items, if the kind is a file, so an image would be a file type, and if it's of an image ping, so that's the format, we can read that as a file. We'll create a blob from that data, which is essentially a file. And then we'll create an image on the fly in JavaScript, and then create, calling window.url.createObject URL creates sort of a handle to that file that we just cut and paste. And then I append it to the DOM. So utilize things that people know about from the desktop world. Now that's getting files, into your application, in your modern web app. How do you get things out of your web application? Once you create something in the web app, maybe users want to, get it back out, or not necessarily save it to the cloud, but save it to their desktop. And so again, we can use HTML5 drag and drop, which is also a feature in HTML5. But I can also drag files out of the browser as well. So for example, I basically just have a link here that points to a PDF. If I click that link, right, it just opens a URL to a PDF. But with a little magic, if I specify this certain URL format with the MIME type, so application PDF, the file name I want to save it as, and then the absolute URL to that file, which is the one you just saw, I can use drag and drop to drag this file outside of the browser window, and it saves to the desktop, the native desktop. And just to show you that it's the same file, it's the same PDF that we just had on the web. So that's really cool. There's no excuse for data transfer now. You can get stuff in, you can get stuff out very easily. And so the way that worked was basically set up, I looked for all links with the drag out class, and set up a file listener for that. So on the drag start, when I start to drag that file, I'll set this special download URL. And this is a special property in Chrome that you can use to specify this ability to drag files out of the browser. And I'll set that download URL to this particular string, so that MIME type, file name, absolute URL. Next thing we can do, and I'm really excited about this one, is the ability to create folders and files in JavaScript now. So HTML5 has an HTML5 file system API that you can use to read and write files and directories to. So again, this is something people are very familiar with on the desktop. You saw me drag files and folders in. Now we can do that too inside of our web applications. So WebKit request file system will get you access to this sandbox file system. You give it what type of storage, either temporary or persistent storage, the size of the data you're going to store, and the whole API is completely asynchronous. So there's always going to be some kind of success callback. There's always going to be some kind of error callback. And so if I wanted to, for instance, save a file, say I download a file using XHR, I can save that file by calling the file system root. I'll create the file using get file. Whether or not it should be created or not once I first do this. So, and in this success callback, we'll use the file writer API. We'll create a file writer object. We'll use the blob builder to essentially construct the file on the fly. This is another great API. And then just save that out to the file system. So this is kind of complex, but it's best served with an awesome demo. So this is essentially a terminal that I've written in HTML using CSS and some JavaScript. But what it illustrates is wrapping the file system API, the power of the file system API under this application. So let's see here. Just to show you this is a web app, right? I can control zoom in on this page. It's just web fonts and text. Let me zoom out because I can't see. So we've implemented a number of commands here. I have audio, so really replicate a terminal. I can ls, so I can list everything in my HTML5 file system. I can cd into directories. I should be able to open some of these. So it's a blank file. Fooled you guys. But the really cool thing about this particular demo is that we have this 3D mode. So if you've ever seen Jurassic Park, this is what we were going for. So this is essentially, in the bottom here is the terminal that is slid out of the way using CSS. And on the top is an iframe with WebGL. So we had a colleague build some WebGL, and I basically just pass him commands, and he renders what needs to be rendered. So I can cd in, I can cd into directories, right? And this is all WebGL, so I can see the files in there. It's really kind of pointless, but it's a really cool representation of what is going on under the hood. I can make directories on the fly. So really cool, really silly use case of using the file system API to run a 3D demo, and I can get out of it with 3D. Actually, what I should show is, so I can drop files into this web app, as I just showed you, right? So we added Chrome glasses. So it's using file drag and drop to import files and add those to the file system API. And of course, if I refresh this, Chrome glasses is still there. Let me see if I can open that one. Aha! So there you go. I imported that file into the file system API with drag and drop. Everything we just talked about. So that's the file system API. Next thing is the ability to take a web application offline. So it's very important. We've had some Wi-Fi issues today. HTML5 has all of these APIs to deal with connection issues and to take your data offline. And there's really no excuse not to take and build an application that works offline. And that's a very different notion of what we've done in the past. A web app that works offline, that's a little bit weird. But there's app cache, right? App cache is for your static assets, your CSS, your JavaScript, your HTML, so you can view all that offline. There's things like the file system API for storing complex structured data like files. There's IndexedDB for storing also complex structured data and also querying for that data. So there's databases now in the browser itself. And then there's local storage for simpler sort of key value pairs. If you have to save user settings, for instance, you can store those very easily with local storage. Being able to detect whether you're online or offline, so online and offline events. This was something that's been sort of a feature request for a long time, but now we can detect in our application when we actually do have a connection or not. You want to do things like persist user data. So I gave the example of a big form before when somebody's filling out a form in your application. The last thing you want to do is have the browser crash or the page refresh for some instance, and the user loses all of their email that they're typing out or something. So that's terrible. That's not a great user experience. So what we can do is use local storage and save that and persist that as the user is typing. We can set up an event listener as the input changes. So as many times as I refresh this page, that data is still stored. I can recall it anytime I want from the file system API, or excuse me, the local storage API. So we're just saving the value of that text field as the user's typing. If you're interested in any of the offline technologies, some of them are very complex. And there's a great library called Lawnchair that has abstractions for local storage and IndexedDB and WebSQL. So it's basically one API here that you call getters and setters to store data in a number of these different APIs. It makes the entire thing super, super easy. Oh no. Anybody know what slide I was on? Aha. In a modern web app, we can take some of the common patterns people have used in the mobile space or the desktop space and bring those to the web. So again, with very little code or very little markup, I can really have a lot of power under the hood. So this X WebKit speech attribute added to any input field can speech enable your application. Coffee Tokyo. Coffee Tokyo. So it worked. That's fantastic. This has been something that, oh, thank you. So with one attribute, Chrome has this little icon. You can speech enable your entire app. You know, mobile phones have been able to do this for a long time, right? You can talk in your phone. Now that's available in web applications as well. Sorry. And so the way that works is that you can listen for the change event just with that attribute and get the utterance. So this is what you actually get back from this result set. And of course, Coffee Tokyo was the best option at 93%. And then a couple of other ones here. Coffee Tokyo Drift, that's kind of funny. But at very low confidence levels. So you can know exactly what the speech servers are giving you back. Another thing you can do is keep users informed. A lot of these new APIs give you interactions with the desktop. You saw drag and drop. You saw access to the microphone via the speech input. And you can use the notification API to keep people informed. So I'll just show you an example of creating a notification. This is what a notification looks like in the top right corner here. I can give a little logo, give a title, I can give simple text. And so you can imagine this is Calendar or Google or Gmail, for instance. You get a new email and you get informed. You don't have to be viewing the application, but if the notification has a link, you can pop over to that and open up the app. Now it's not just HTML, or excuse me, it's not just text. You can put any HTML inside of the notification. So this is just an HTML5 video. It's playing in this notification. We'll kill that. It's a fun video, though. And the way that works is that the user has to grant permission to use a notification. So I've already done that in this case. And I can create a notification using the WebKit notifications. I can send it that little icon picture. I can send it a title and the text to display. And you saw that it disappeared after a certain amount of time. I can just call after 6,000 milliseconds, 6 seconds, to close that window using the close method. We talked a little bit about the offline technology, and we had, I believe, a whole session on it either earlier or later today. But you should really treat performance as a feature. Google, this is something Google is known for. People visit google.com, they type in a search query, and it's instantaneously returned to them. And so what we found is if we make applications, Gmail, Google Search, Google Docs, if we make them very fast, people are more likely to return to them. And so if you treat performance like a feature, users will engage with your application more. So I mentioned some of the offline APIs, but these APIs, there's sort of two wins out of them. One is that you get your application offline. That's great. But you also speed up your application. You don't have to, all the data is cached, for instance. You store local data in the databases, in the local storage, in app cache. So you're not having to retrieve things from the server. You're just firing that app up instantaneously, and it works a lot faster when it starts up. You can take advantage of things like CSS3, right, for animations. No more do we need to have a JavaScript library to do animations. We can do that natively just using a little markup, using CSS transitions and hover states. Web workers, another awesome feature of HTML5, right? The ability to do multi-threaded JavaScript is totally new to HTML5. So you can spawn up multiple tasks and really do some heavy computation now in JavaScript, while still keeping your application very, very performant. So you might be wondering, I showed a lot of cool stuff. I showed cool stuff earlier in the other talk I gave. So what about older browsers? And the answer to older browsers is what's called a polyfill. And these are essentially just JavaScript libraries. Polyfills are JavaScript libraries that implement the API that you're interested in using in older browsers. So for instance, if you wanted to use HTML5 video in IE6, can't really do that natively, right? But with a polyfill, you can. So a polyfill, for instance, would try to use HTML5 video first and then fall back to something like Flash video. So Flash is supported there. So that way, all your users get the ability to play video, just at different levels. Now, for everything else, right, for things that can't have polyfills, things that can't be, you can't create a JavaScript library for, there's ChromeFrame. And this was talked a little bit about before, but I just want to re-emphasize how awesome ChromeFrame is as a web developer. If the user has this thing installed and your site has this meta tag on it, the whole page is going to be rendered as if it were in Chrome. So you get lightning fast JavaScript, you get perfect CSS, you get the ability to do web workers inside of IE6 or use the web audio API inside of IE6. That is crazy, but awesome. It's really cool. So that's how you bring everybody else along and build a really awesome app that can work everywhere. Some other really cool libraries that you probably should be aware of are HTML5 boilerplate. So this is a great tool if you're just getting started, building an HTML5 application for the first time. Boilerplate is the way you get there. It's got some great cookie cutter sort of markup, build tools, CSS minification. It has the ChromeFrame meta tag by default. It's a lot of great stuff that you have to do over and over again when you're building an app for the first time. They've taken care of all of that. Another great one is Modernizer. So as these new HTML5 APIs come out, you want to be able to detect if the user's browser can actually support them. And so Modernizer is exactly what that it does. So if you build an application that uses a web worker, Modernizer allows you to test the browser to make sure it can use that. If it can't, then you have some kind of fallback solution where you don't have the web worker included on the page. And of course, there's other libraries like jQuery, Dojo. I mean, these are web developers' best friends, right? And we've been using a lot of these for a long time. Okay. So here's an old internet saying, right? You build something awesome. I've kind of talked a little bit about how to do that. Step 2, I have no idea what step 2 is. And then step 3 is profit. Step 3 is to make money off of this awesome thing you just built. So big question mark in the middle here. And that is where the Chrome Web Store comes in. And the Chrome Web Store has a few different goals. The first is to get eyeballs on your application. If you build something really awesome, you want people to discover it. You want people to find it. And it should be very easy for that to happen. If you do a google.com search and you search for amazing photo application, you're probably not going to get the correct results. I mean, Google will do its hardest to give you the results, but how do you know if the application is great? How do you know if, what kind of reviews are users saying about it? The Chrome Web Store gives you access to over 200 million users. That's a huge user base, right? So they're using Chrome, they can install these applications, they can launch them, they're synced with Chrome. So very easy for you to touch a lot of people really quickly. This is a screenshot of the new Chrome Web Store. So we just launched this, I believe last week or the week before. So completely redesigned Chrome Web Store, a lot easier to navigate, new categories, launched in different countries. And what the Web Store is meant to do is giving you the ability to monetize a web application. And this is a new concept, right? Usually you hit a URL for free and you use a web app. But now developers can sell web apps. So you can do things like a one-time payment. You can do things like in-app payments. And there's a whole session, actually, right after this one, if you want to learn about how to monetize a web app on all of this stuff. So $5 registration fee, you're in the store. My favorite part about this is that there's no approval process for the web store. We don't lock you into any particular technology. We don't have an approval process. Once you upload your application, it's there for users to install and download. So you can build your app in Flash. You can build your app in Java. You can build your app in Silverlight. You can build your app in HTML5. It doesn't matter. As long as it's a web app, it can be in the store. In 41 languages all over the world, and we're adding more and more as the months go on. A couple of great success stories from this being in the web store. So World Golf Tour saw 23% more users and 147% more spendage. People are purchasing more things in their app just by putting their app in the web store. So they already had a web application, they uploaded it to the store, and boom, more user engagement. SpringPad, similar awesome success story. 100% more engagement just by uploading their existing application and putting it in the store. And what you get in Chrome is the ability to have a quick launch to your application. So this is the new tab page, as we call it. And so I can list my favorite apps, the ones I've installed, and really have very easy access to them. So the process is very simple. I create an application. I'll upload a manifest file, include graphics for my screenshots of the application, videos of the application, and then publish that to the store. The way that works is by creating a manifest file. So if I already had a web app, I would just wrap that in this metadata. So title of my application, I'll give it a description, any of the icons associated with the new tab page links. But the real cool thing about the web store, being an app in the web store, is that you get more power than a normal HTML5 application. So for instance, if I used the unlimited storage permission, I have the ability to read and write unlimited amounts of storage data using IndexedDB or the file system API or local storage. Otherwise, I'm limited to 5 megabytes. That's what a normal web application gets. Again, there's a session on this right after this. But once you have your app in the web store, you're selling it, you're monetizing it, in-app payments gives you the ability to prolong that and really have a lifetime of your app. So there's no transaction fees, no monthly fees, no sign-up fees. It's very little overhead to use in-app payments. So that's all I have for this presentation. I want to leave you with one last thing, and it's what I started with, and it's really to build a great user experience. If you do that, all else will follow. Users will use your app, engage with your app. Some of the things we talked about are how to get there. If you're interested in staying up to date with a lot of the new HTML5 APIs and technology, chromestatus.com, awesome website. HTML5rocks.com is a site that my team maintains. We write tutorials, we have demos, we have samples. You can learn a lot about what's new in HTML5 and how to build a great modern web app. I will leave this one up, but that's all I have, and I really appreciate your time. Thank you for coming to this session. I've had a blast in Tokyo so far. Thank you.
以上でセッションを終了させていただきます。